Welcome to video 10.1b, radius chord relationships. So here we've got three theorems. If the radius is perpendicular to the chord, then the radius bisects the chord. So basically, if perp, then bisect. If the radius bisects the chord, then it is perpendicular to the chord. This is the converse. So if bisect, then perp. Finally, if a segment is known to be the perpendicular bisector of the chord, then we know that that segment passes through the center of the circle. So if this segment is both perpendicular and bisects that chord, then we know somewhere along the line includes the center. That segment goes through the center of the circle. Okay, so those are the three theorems. Now let's do a few examples. Here's the first one. Example 1. The radius of circle O, so again, whenever you see a circle with a dot in the center, that means circle O, and O would be the center point of that circle. So the radius of circle O is 13 millimeters. The length of chord PQ is 10 millimeters. Find the distance from PQ to the center of the circle. Remember how we define distance? It's that shortest or perpendicular distance. All right, so let's draw a picture. That's my circle. That's point O, and then I'll have a chord and I'll call it PQ. Okay, so the distance from PQ to the center is what we're trying to find. So I'll just label that as X, and I know that I would have if perpendicular, then bisect. That's one of these theorems over here. They said that the length of the chord is 10 millimeters. So this whole length here is 10, but if I chop it in half, I'm going to get a 5 and a 5. So I'll just put a 5 over here and a 5 over here. It says the radius of the circle is 13 millimeters. Oh, maybe we should draw an auxiliary line. That is the radius, and that's 13. Of course, I could have drawn a radius over there, but that would have helped me in the problem. I now have a right triangle. I've got a side length of 5, a leg is 5, a hypotenuse of 13, and I'm trying to find that. Oh, I'm thinking of the 5, 12, 13 right triangle, so this must be 12. So the answer would be 12 millimeters. And that's the distance from the center of the circle to that chord. So there you have it, 3 theorems with the radius chord relationships and one example on how to apply them.